All right, welcome back. This is section 4.2. We've got 3 questions from the homework. 1 and 2 pretty much kind of sum up the entire section. And then we've got a word problem here, number 7. This is substitution, where the idea is, because we're looking for the point that makes both equations true, what we do is we kind of combine the equations together. We're looking at how to take part of one and substitute it into the other. So, my cat. So in the first one, you can see how everything is set up really nicely where the y is all by itself in that second equation. If y already equals 2x minus 5, is it possible that I can just put 2x minus 5 in place of the y in the previous one? So instead of x plus 2y equals 10, instead of x plus 2y equals 10, I'm going to write what y equals. And we know from the other equation that y equals 2x minus 5. Now you'll notice that I've got an equation just like chapter 2, where it's a single equation, a single equal sign, one variable. And I can solve that. We can do that pretty readily. X plus 4x minus 10 equals 10. I combine these together to give me 5x minus 10 equals 10. Adding 10 to both sides gives me 5x equals 20. Divide both sides by 5, and x equals 4. And the nice thing about the substitution idea is if you look at this isolated y, we can figure out what y is pretty readily by simply taking the 4 and putting it right into that underlying expression. So I know that y is going to equal 2 times that x value minus 5. 2 times the 4 minus 5. What is 2 times 4? I hear you say 8 minus 5, which is 3. So my solution then is the point 4, 3. 4, 3 is the point that makes both those equations true. You look at number 2, you can see how this doesn't work as nicely because there is no variable that is already isolated all by itself. There's no x equals or y equals. But one of those equations has a plain x or y in it, right? This one right here, there is a y that's very easily isolated. So what we're going to do is we're going to rewrite this system as I'm going to add y over to this side to give me 4x equals 14 plus y. Well, then I want to subtract the 14. So I'm going to subtract 14 from both sides, and that will give me 4x minus 14 equals y, or y equals 4x minus 14. I subtracted the 14 from both sides, I added the y to both sides, and that got me the y isolated. This equation here will stay exactly the same. And I'm, again, going to underline this idea right here. Y equals 4x minus 14. It happens to be another y. We could also do this for x if x were isolated. So now I'm going to take this equation here that is 9x minus 2y equals 33. 9x minus 2y equals 33. Well, what is the y? Why is it blank? Because I'm going to replace it with the other equation y. 4x minus 14. Now I can solve this equation. Looks like the numbers are pretty ugly. I'm hoping it works out nicely. A minus 2 times the 4x is a minus 8x. A minus 2 times a minus 14, that's a minus times a minus, and negative times a negative is a positive. Positive 28 equals 33. It looks like this equation is going to work out pretty nicely. And 9x minus 8x is just a plain 1x, or x. If I subtract 28 from both sides, 33 minus 28 happens to be 5. So x equals 5. Great. If x equals 5, then I can go to this underlined spot right here. I'm writing on a room. I'd keep going, but I can't. Y equals 4x minus 14. What is x again? Can you see that? Oh, barely. Yeah, just barely. X was 5. So I've got y equals 20 minus 14. 20 minus 14 is 6. So my solution is the point 5, 6. Great. So we now know how to solve a system using substitution if one of the variables is already isolated, and here if one of them is easily isolated. Now let's throw some words into this. Right here, the difference between two numbers is 4. 7 times the larger is 11 times the smaller. So we want to create a system of equations for this and then solve it. I know that I've got a larger and a smaller. I'm going to say larger is L and S is smaller. I hate to use S because it looks like one of my 5s. Just be careful on how you write those. But the difference between two numbers is 4. Difference means subtraction. If you take two numbers and subtract them and get 4, well, obviously you're doing the larger minus the smaller if you're getting a positive 4, right? So that means one of the equations is L, large, minus small, needs to equal 4. And then it says 7 times the larger is 11 times the small. That seems to be the other equation right there. 7 times the larger, that's 7 times the larger, is 11 times the smaller. So there's my system of equations. It looks like it's probably pretty easy to add s to both sides. So this equation becomes L equals 4 plus s, and 7L equals 11s. There is my system of equations. Yep, you can still see it. So all I need to do is replace this L down here with the expression 4 plus s, and then it can be solved from there. So that's pretty much it. That is section 2. Hopefully that works for you. I'll do section 3 here in a minute. See ya.